5.
Are they live?
No, it's not live.
I didn't know.
Are you
If it
dumb?
will be or not.
You're dumb.
How would it not be? How could it not be?
Do you see any Ethernet cord or anything plugged
Could be
into this?
Bluetooth.
It's not Bluetooth.
Bluetooth to the internet.
Yeah.
Never heard of such a thing.
What?
Never heard of such a thing.
So are we coming up with this?
No.
Questions? All right, so here's our Lewis structure. Now, how do we go from 2D, 3D? Well, the first thing is we need to figure out how many things do we have coming off the central atom?
4.
In this case, we have 4. So now we look at our handout. Look at the leftmost column. Look for the shape that has 4 things coming off the central atom. What shape has 4 things coming off the central atom?
Tetrahedral.
Tetrahedral. So the VSEPR shape for this one is going to be
Tetrahedral.
tetrahedral. Now, when we draw the VSEPR shape, we do not show any lone pairs on any of the atoms. So this is how we draw it. Any questions on the first one? First example?
Probably.
No? Okay. Let's look at another example. Okay, go ahead and draw the Lewis structure for NH3, please.
Yep.
Are we coming up with this?
Somewhere around there.
Okay. Now, how many things do we have coming off this one?
3.
Not 3. It's actually 4.
I just got delivered. I hope it's the right one. That's not the same one. It just looks like the same box we got the first time. I just wanted to make sure, but
Let's take one.
this isn't the one. Oh, it is the one. Oh, good, it's not the same.
No, it's
When it came in that box, I'm like, gosh, it looks like we got the exact same one. So hopefully this will be one that works for us.
Use that knife.
It is.
Okay.
Thank you.
Great. Thank you.
Where'd you get that
That's
knife?
against the
No, where'd you get it? It's a cool knife.
teacher's
I'll
little
tell you later.
secret.
Okay, we have 4 things coming off of it. We have the 3 hydrogens, right?
Yeah.
But we also have a lone pair. So when we're counting how many things are coming off the central atom, we also have to count lone pairs as well. So since we have 4 items coming off of it, column on the left, which shape has 4 things coming off of it?
Triangular, oh, tetrahedral.
Tetrahedral. But since one of the things that we have coming off of it is a lone pair, we have to move 1 spot to the right of tetrahedral. So what's the shape that is 1 spot to the right of tetrahedral?
Triangular, or triangle pyramidal.
Pyramidal.
Trigonal, pyramidal.
Trigonal. Pyramidal.
Close enough.
Tried.
Alright, so NH3's VSEPR shape is trigonal pyramidal. And as I said, we don't want to show any lone pairs. Are they there? Yes, absolutely. And what's happening is the lone pairs on the nitrogen are pushing the bonding electrons to each of the hydrogens out, and it gives that pyramidal, that trigonal pyramidal shape to it. Read?
So on this paper, it has the lone pairs like on a
Yeah.
thing. Do we not put that?
For VSEPR, no, we don't show any lone pairs.
Alright,
Okay? Any other questions right now?
no, sir.
No? Alright.
Did you WD coordinate that fuel bit or what?
Excuse me?
Did you put some WD on it or what?
No, I don't know what they did, because it was like that when it came back. This thing bounces around a lot, but... Alright, let's see. What do we want to do for the next one? Okay.
What are you doing?
Okay, XEF2.
Don't worry about it.
Figure out the VSEPR shape, please. Not VSEPR shape, but figure out the list structure, please.
What happened?
I don't know, I thought it just looked like it was leaning backwards.
Oh.
So, last week, the legs were getting pushed down because whenever they move it, they got pushed down on the camera. Are we coming up with this for our Lewis structure?
Yep.
Questions?
Whoa. Yeah, that's what you got.
Oh.
You hope? Okay, so how many things do we have coming off the central line? 5. 2 of them are the fluorine atoms, and then we have 3 lone pairs, right?
Right.
So,
Probably.
left column, what shape has 5 things coming off of it?
Triangular bipyramidal.
Trigonal bipyramidal.
Yep.
Okay.
Now, we have 3 lone pairs, so how many spots do we need to move to the right?
3.
3, so what shape is 3 spots to the right of trigonal bipyramidal?
Linear.
Linear.
Oh,
Come on, read 3, not 2.
I know, you're right.
I know I'm right, otherwise I wouldn't have said it.
You're right.
Okay, so the VSEPR shape for XEF2 is linear. Okay, are you kind of seeing how this handout works?
This handout helps a lot.
And if you talk to some other people that have other chemistry teachers, they don't even show you this. I
How
found
did
this.
you figure that out? How did you figure that out then?
How did I figure it out?
Like, how would you figure it out if you never? Dude,
The way that I learned, it was 3 hours in the lab with a quiz at the end of it. I just learned quickly. And this was in college. And the quiz was, you had one, I Get that off.
What?
Get it off.
I got a good shot of you.
The quiz, you had 2 opportunities to get it right. Miss on the first one, you have the second one. If you didn't get it on the second one, you failed. So that was kind of motivation to learn this stuff real quickly. I found this to kind of help out with teaching how to do this stuff. Okay? But we're kind of seeing how this is working out a little bit.
Oh, yeah.
All right? Try this one on your own.
Probably bet.
Try to figure out the Vesper shape of it.
Oh. Probably.
Maybe. Does this have a double bond?
Are we going up with double bond?
I guess we have to.
Yeah, it might be a good idea.
Maybe.
Probably.
Is this what we're coming up with our Vesper shape?
You bet.
Or not Vesper, excuse me, our Lewis structures.
You bet.
Okay, so we have how many things coming off the central atom?
3.
3. The 2 oxygens and a lone pair, right?
Yep.
So what will our Vesper shape be?
Bent.
It'll be bent, because with 3 things, we go to trigonal planar. Then with one lone pair, we move 1 spot to the right, and we have
Angular.
angular or bent.
See, that's where I didn't know. I didn't know we had to show the double bond.
Yeah. Like I said, if you have a double or triple bond, you gotta show it in the Vesper shape as well. Okay?
Alrighty.
Any other questions right now?
I think we're good.
So if it was far or like if it was behind or in front, how would we show a double bond?
Double bond's always gonna be in the same plane. Get that camera on.
It's not on your face.
Yeah.
I just got it videoing you. Don't worry about it. You got some good footage on here, I tell you.
Sure.
Zoom it in.
Sure.
Beautiful footage.
Look what you made. That's because of you, Carson.
It's not that hard.
No, actually, this was one I was gonna show you, so. Go ahead. Figure out the Lewis structure for this one, please, and then just stop.
No, you'll show us something. I have a hard time figuring out, like, in a big thing like this, what, like, there's gonna be 2 central atoms in there. I have a hard time figuring out which two are gonna be bonded together.
Well, like I said, it's, the two central atoms are gonna be the ones that have the more unpaired electrons, okay? Then, this is kind of telling us how things are gonna, what things are gonna be bonded to what.
Oh, see, I got it now. Yeah, that's what I got.
I hope.
Is this what we're coming up with?
That's you.
Okay, so our two central atoms, one is silicon, the other one is
Nitrogen.
nitrogen. Okay, so to figure out our VSEPR shape, we first look at silicon. How many things does silicon have coming off of it?
Trace.
Four.
You bet.
Oh yeah.
3 chlorines and the nitrogen, right?
Yeah.
So what kind of shape will silicon have at
Tetrahedral.
tetrahedral?
Yep.
Okay, now, nitrogen. How many things do we have coming off nitrogen?
3.
3. So its shape is going to be
Trigonal plane.
trigonal planar. Okay, so how in the world do we draw this?
Well, you just bond the two together.
Well, let me show you.
Probably.
Okay.
Let me show you.
Oh, we're switching.
We just kind of tilt the tetrahedral up so that the bond between silicon and nitrogen are in the same plane.
So this is the tetrahedral right here. SL,
Tetrahedral,
right?
trigonal planar.
Yeah.
Okay? So when we have a more, I guess you can kind of say complex atom, you have to look at each individual central atom and see what's going on with it for its VSEPR shape.
What's the biggest one you've ever had to draw that I was like, what's the biggest amount of central atoms you can have?
Infinity. Because you kind of think some protein structures, they're huge, right?
Some of it take up this whole whiteboard.
Yeah. But a lot of it, with a lot of the protein structures, you're gonna see a lot of tetrahedrals. Probably some trigonal planars in there as well, depending upon what we have coming off the carbon atoms. Okay. But you see how to use this handout to figure out, go from the low structure to the VSEPR shape? Yes, no? Do we have any questions right now? Okay, so what I'd like for you to kind of do now, do the next part of the assignment. We did low structures on Friday. Today, I want you to figure out the VSEPR shape.
Can I stop this?
Yeah, go ahead and stop.